Hello, physical scientists. Ms. Getz here. I'm going to help you think through our quiz. It's not actually a quiz. Really, it's meant to be a practice assignment. And if we were doing it in class, I would have given you feedback as you worked on it in the physical classroom. But that's pretty hard to do in distance learning. So the idea is that you can take this a couple of times, look back at your answers, and think about what you would do differently. So if you haven't tried taking this once, I would actually pause this video, try the quiz once, and then come back to this video. Because what I'm going to do is I'm going to walk through each question with you and have you kind of think about what you think is going on. So we start out with this first one. It says, a book is resting on a table. And so each of these questions has some object that we're going to look at in a situation. And so the idea is that we're going to drag and drop the forces and the directions of the forces into the free body diagram below. The formatting is a little bit frustrating, annoying. I find it very annoying. Anyway, and so that's why I'm going to walk you through a little bit. And the other thing I think people have been struggling with is how to really draw these free body diagrams. So first off, for every single one of these, you want to think, this object, what objects is it interacting with? And the book, it's interacting with the table, and because it's like on it, it's like sitting on it. And then the other object that the book is interacting with that you might not normally think about is the whole Earth, the planet Earth. So I know that the book needs to have that force from the planet Earth, and in fact, each and every one of these free body diagrams will need to have that. And that's force gravity, which can either be an arrow up, it looks like, or an arrow down. And force gravity always pulls objects down, so that's a good place to start for each one of these. Force gravity is going to pull it down. So notice that I'm putting it in the box that's at the bottom of the free body diagram box because it's pointing out of this little book box. So it points out, pointing force of gravity on the book is pulling it downwards. Then the book is interacting with the table and it's going to be putting a force on it, holding the book up. And so the table is actually pushing upwards on the book. And one object pushing on another object is called a normal force. And that is pushing upwards on the book. So I'm going to put that upwards force in. So the thing to really notice, and I've seen a lot of people doing this where they have their force pointing down up on top and they have these switched around. So you want them to be coming out of the box. Notice this one comes out of the box. It points downwards. This one comes out of the box pointing upwards. So the up force goes here. So I'm not going to answer each one of these for you, but I'll help walk you through a couple of them. Similarly, for our skydiver, we're going to think about what forces are on the skydiver as they're falling towards the ground. So you can kind of think about, well, again, that force gravity, it's always going to be there every single time. And then you're going to think about, well, what is it that's slowing the skydiver down? What force is pushing upwards on them? They're not resting on any surface, so it can't be a normal force. But they're interacting with something. And so you think about what force that would be. And then drop your forces in. Again, force gravity is always going to point down out of the box. I'll let you figure out which force points up here. So then on question number 3, we get a little bit more complicated. We have an orange person pushing a wooden block to the left on the frictionless surface. So frictionless surface means we don't have to worry about friction. There will be no force friction at all. So I want to make a free body diagram for the wooden block. And so just like I mentioned before, every single time that force gravity is always going to be there and it's always going to point down. This one's formatting got a little messed up. This downwards box is supposed to be right here. So there should be, this box should be right here, but it's the force pointing down. That'll be force gravity. And then you'll have to say, okay, well, I know that the person is pushing on the block. The orange person is pushing on the wooden block to the left. So that would mean that we'd have an arrow coming out here to the left with the type of force that the person is pushing with. And then we'd have the ground is supporting the box and it's pushing upwards on the box. So that would be a force pointing upwards here. And we'd think about, well, what type of force is that? So it's the box pushing on the ground. And you'd figure out what types of forces you'd like those to be. And you'd drag and drop them in. Then we switch our situation a little bit. Now the orange person is pushing the wooden block still to the left, but now there's friction. So this free body diagram is actually going to be really similar to the last one. And it also similarly has the formatting a little messed up. This is the downwards box. It should be right here. So that'll be my arrow pointing down, and I'll just give you that one right now. That's that force gravity. It's always there. And then you'll think about, well, again, probably the same forces of the person pushing against the box. We'll be pushing to the left. We'll have that force from the ground holding the box upwards here, so this should point upwards. And then something is slowing the box down. That interaction between the box and the ground sort of rubbing together, that's going to be this force pointing backwards. So you'll want to kind of think about what you think that might be. And then this one has a lot of options, I know. So think about what you want the forces to be, then look for that arrow with that name. Then our next one is a little bit different. We've got a blue person pulling a rope connected to a cart on a frictionless surface. So that means we won't have to worry about friction at all. And so we want to do a free body diagram for the cart. So for this cart right here. So that means that, oh yeah, hey, that force gravity, it's always going to be there. It'll come out, pointing down out of the bottom of this cart box. And then something will support the cart pointing upwards. And then the cart is getting pulled with a rope to the left. So that means that there'll be this arrow coming out to the left with whatever type of force there would be if you were pulling with a rope. And then our very last one, this is the hardest one, by far actually, the hardest one. We have a softball player and they are sliding to the right on a surface that has friction. So here's the softball player, they're sliding along the ground here, like they're diving for the base or maybe diving to catch the ball or something. So just like usual, there's going to be this force gravity on the softball player, always there, pointing downwards. The surface will hold the softball player up so they don't fall through to the center of the earth. So you'll think about what force will be holding them up, pointing up here. And then you have to think about, well, they're sliding to the right and the surface that has friction. So that means they're going to rub against that surface. So there'll probably be a force friction. You want to think about what direction force friction will be in. Is it helping them slide to the right? Or is it slowing them down, opposing their motion to the right? And then the last thing to think about, and this is one that's really hard, is that the softball player, do they have something pushing them to keep going if they're sliding? If I take this pen and I slide it along my laptop, did I need to keep sliding it that whole time? My laptop is on my lap, it's like slanted. Does my finger keep pushing against it the whole time that it's sliding? So it's something really to think about. Does there need to be a force pushing the person forward for them to be sliding? If there is a force, think about what object is pushing the person forward so they keep sliding. And if there isn't a force that keeps the softball player sliding, we actually have a no force here box. So, my physical scientists, you want to do your very best on this quiz. I hope this video was helpful for you if you're struggling a little bit with it. And please feel free to shoot me an email if you can't quite figure out why you have a question wrong. I'm happy to take a look and help you out. Good luck.